In this video, we're going to talk about how to solve a trigonometric equation. We've divided up this topic into two videos, so this would be part 1. So some of the strategies that you might use to solve a trig equation, there can be several different types, and we're going to try and give you a look at a lot of different kinds of equations that you might solve. So here are some things that you might want to think about. Number 1, is the equation linear or quadratic? Right? Linear meaning my trig function is only raised to the power 1, or just the normal trig function. Quadratic meaning I have some squares or some extra powers in there. And that's going to determine how I decide to solve, right? Just like it determines how I solve in algebra. It's the same idea. Number 2, if I only have one trig function, I want to make sure I isolate that trig function, and then I should be able to solve using the inverse trig function. Number 3, if I have more than one trig function, I might want to try to solve by factoring. Sometimes I can factor, and by doing that, I kind of break up the two trig functions into separate factors. And then I can solve just like I would solve by factoring in algebra by setting each part equal to 0 and using that zero product property. Number 4, if the equation is not factorable, then I can use the quadratic formula. And then number 5, we may need to bring some identities into the conversation to change the form of the equation so that maybe we can use an identity so that we can write it as one trig function. Or, and I think usually that's how they're used, or maybe we need to use a double angle identity or a half angle identity. All right, so let's try this out. First we have solve this equation. We're going to start by finding the exact solutions in the interval from 0 to 2 pi. Okay, and the book that we're using has this a standard where if they use the variable x, they're going to be talking about radians, and so we'll use the pi, right, or the 2 pi. If they are using theta, then they're going to be talking about degrees, so from 0 to 360. Okay, well, let's just solve this just like we would any other algebra equation. Instead of isolating x, we're going to be isolating the sine of x. So we're doing all the same steps we would normally do to solve. We would subtract 3 from both sides. Divide both sides by 2. This is the point where we might want to bring in our unit circle to help us out. This is where we would use our inverse trig function. All right, so remember on the unit circle, the place where the sign shows up is as the y value. So here we have 1/2 as a y value when we're using the angle pi over 6. So you could think of this also as sine inverse of 1/2. Okay, and the places where the sign is going to give us a positive 1/2 are both at pi over 6. And if we kept going all the way around the circle, right, till just before we got to pi here, right, that would also have a value of positive 1/2. So pi would be 6 pi over 6, so this would be 1 less than that, so 5 pi over 6. Okay, so that's kind of the process. We're using a lot of algebra in the front, and then we're going to use the inverse trig function to look for the angle, and then we're going to use, really I think, we are going to be thinking a lot about the unit circle to decide what angles give us these values, right? And it may be more than one angle. Let's try another one. Let's say we have 2 cosine squared of x minus the square root of 3 times the cosine of x equals 0. Okay, this is one where factoring might be good. Notice we have cosine squared. And so just getting cosine by itself is not going to work here. We also have 2 appearances of the cosine, so that would also make it difficult to do that. But factoring will work very well here. So let's try that. So let's factor out a cosine. So if I divide out a cosine, I'm going to be left with 2 cosine of x minus the square root of 3. I should point out that we can only use this factoring process if we have 0 on one side. So if we hadn't already had 0 on one side, we would want to achieve that 0 first and then do this process. Because what we're going to do next is if these two things multiply to be 0, then one or both of them must have been 0 to start with. So that's that 0 product property that we use a lot in algebra. So we're going to set each part equal to 0. And then we're going to solve from there. Let me start with this part. So I'm going to add my square root of 3 over to the other side. And I'm going to divide both sides by 2. All right, this may be the stage where you want to bring in your unit circle. Here, we'll do this. So for the cosine of x equals 0, you want to look for a place, or more than one place, where the cosine is 0. This would definitely be one place, right? Cosine is the x. So pi over 2. You could write it like this if you like. This is kind of what we're thinking. We do this, right? So x could be pi over 2. I don't have the whole circle here, but if we went all the way around down here to the bottom, we would also have a place where the cosine was 0. So that would be at 3 pi over 2. Okay, so those are 2 solutions. And then let's do the same thing for this piece. So cosine of x equals square root of 3 over 2. That is pi over 6. And this is where it's going to be positive, right? Another place where it would be positive would be down here below. So negative pi over 6 would be the same as, I'm thinking, 11 pi over 6. All right, so we actually get 4 solutions, right? We get pi over 2, 3 pi over 2, and then pi over 6, and 11 pi over 6. All right, let's try a couple more. Here's number 33 from your book. This is one where you would need to use an identity. Maybe you're like me and I struggle remembering this one, so I always derive it first. So I'm going to do that here in case you're like me. So to get an identity for the cosecant, I need these two to match, right? So I think I can use an identity to do that. The identity for the cosecant is the one where I divide everything by sine squared. So this is going to give me 1 plus, this is the cotangent squared, is the cosecant squared. That's the one I need, right? So in place of the cosecant squared, I'm going to put in 1 minus cotangent. Oops. Okay, and then this is sort of like an algebra equation. I have a squared term, a term where it's to the first, and a constant. And I'm used to seeing that written in this order. So now, because of the cotangent squared, I might want to think about solving by factoring. I think that's a good strategy because this is something that I can factor. So to get cotangent squared, I must have cotangent and cotangent. To get 1, I must have 1 and 1. And then to get the middle, minus 2 must be a minus cotangent and a minus cotangent. So at this point, I would set each part equal to 0. Since they're both the same, I really only need to do that once. Oops, minus 1. Then I'm going to add my 1 over. Okay, the cotangent is 1 over the tangent. So really this is the same as the tangent of theta is equal to 1. So really what I'm looking for is the inverse tangent of 1. Again, this is where it would be good to pull out our unit circle. So the tangent, again, is the sine over the cosine. So it's going to be 1 when they're the same, which is 45 or pi over 4. Right? This problem is done with theta, so we're going to use degrees. So 45 degrees would be one place where it's positive 1. Think about where it has the same sign, not here. But in quadrant 3, right, they, both sine and cosine are negative, so the negatives cancel. That's another place where the tangent would be positive. All right, so this is going to be at 45 degrees. And in quadrant 3, we just have to think about it. 180 plus 45, which would be 225 degrees. Okay, let's do one more. Here's number 58. So I think the first thing we'll do here is we'll multiply this out since we just have the one trig function. This is going to give us tangent squared minus 2 times the tangent equals 5. Since I have a tangent squared, my first thought is to try to do this with factoring. So I might want to get a 0 on one side. So I'm going to subtract the 5 over. Okay, so then I'm going to think really hard about, can I factor this? I need two numbers that multiply to be 5 or negative 5 and add to be negative 2. 5 and 1 are my only choices, and those definitely don't add or subtract to be a 2. So I can't factor this, which means I'm going to need to use the quadratic formula. I wanted to show you at least one of these. Okay, so hopefully you have the quadratic formula memorized. It looks like x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And this is something that solves an equation that's in this format. Okay, and we have that format where instead of x, we have tangent of x. So think of there being a 1 here for the a. Tangent of x squared is like x squared. Negative 2 would be the b. Tangent of x is replacing x. And negative 5 would be the c. So when we plug this in, really what we're solving for right now is tangent of x. So we have the opposite of b. I'll write it out just so it's clear. Plus or minus the square root of b squared, so negative 2 squared, minus 4 times a, which is 1, times negative 5, which is c, all over 2 times 1. So that's 2. Plus or minus the square root of 4. Negative times the negative becomes a plus 20 over 2. So that's 2. Plus or minus the square root of 24 over 2. Here's where our algebra skills are coming into play here, right? Remember, 24 is 4 times 6. So I can break it up as the square root of 4 times the square root of 6. So that's going to give me 2 plus or minus the square root of 4 is 2 times the square root of 6 over 2. And both parts get divided by 2. Anything outside the radical and anything in front of the plus or minus, both of them. So now I'm going to have tangent of x is 1 plus or minus the square root of 6. Okay, so let's do this with our calculator. So tangent of x could be 1 plus the square root of 6, and tangent of x could be 1 minus the square root of 6. Okay, so 1 plus the square root of 6, let's calculate that. I didn't bring my fancy calculators, I'm using my computer, which I'm not very good at. So this will be about 3.45, I think. Okay, let's do the same thing over here. That's going to give us negative 1.45. Okay, so x is going to be, think of this in radians, right? 3 radians is a little bit more than pi. Okay, so, well, actually this is not an angle, just kidding. This is a value of the tangent. Okay, so let's do the inverse tangent, then we'll get the angle. If you wanted to be really accurate, you could leave all the decimal places in your calculator. I didn't do that this time, but that wouldn't be a bad idea. Oops. We also need to make sure that we are in Radian mode. Let me make sure I'm in Radian mode. Okay, so tangent inverse of 3.45 should give us about 73.8 radians. Okay, and let's do the same thing on this side. So x equals tangent inverse is going to give us negative 55.4 radians. All right, so we'll just leave it just like that. Okay, well, I hope this gave you a feel for how to get started with solving a trig equation. It's definitely going to take a lot of practice because there are a lot of strategies here to kind of get a handle on. But I know you can do it. We'll practice together, and in the next video, we'll add a few things to this. All right, well, good luck.